So if we're given two coordinates, can we find the equation of the line? Yes, we can, and this involves two previous videos. One was finding the gradient from a straight line when we're given 2 points, and the other is using the gradient and one of the coordinates to find the equation. So here's how So those are our two coordinates, the point 1, 2 and 3, 8. Firstly, find the gradient of the line. So from the point 1, 2 to the point 3, 8, we have to go up 6 and across 2, so that gives a gradient of 3. If that was a little bit too quick, you might want to go back and look at the video finding the gradient of a straight line. So the gradient of this 3, and it passes through the points 1, 2 and 3, 8. So the equation of the line is y equals mx plus c, where m is the gradient. Our gradient is 3, so it becomes y equals 3x plus c. We know it passes through the point 1, 2, which means when x is 1, y is 2. We substitute those values in, and we end up with 2 equals 3 lots of 1 plus c. Where did that come from? The 2 was the y value given to us, and the 1 was the x value given to us. From that little equation, we can find that c is negative 1, and hence our final equation is y equals 3x minus 1. And just note for completion, had we used the second coordinate 3, 8 rather than 1, 2, you'll see, and I'll go through this reasonably quickly, that when you substitute the values in, okay, y is 8, x is 3, you end up with exactly the same value of c of negative 1, and hence the very same equation. In example 2, those are our two coordinates. What was the first step? Find the gradient. So from negative 2, 2, we have to the point 2, 4, we have to go up 2 and across 4. So the gradient is changing y divided by changing x, so that's 2 over 4. That's a gradient of a half. So our line that we can see on the screen has a gradient of a half, and it passes through these 2 points here, which we're going to use to find the actual equation. Knowing the gradient is a half means that the equation must begin y equals a half x plus c, and we substitute the values given to us in order to find c. The first point I'm using is going to be the point negative 2, 2. It doesn't matter, you could have used the point 2, 4, as you will see. So when we substitute the value for x and y into our equation, the green value there, that's the y value given to us. The orange value is the x value given to us, and that enables us to find c, which on this occasion is 3, and that's our final equation, y equals a half x plus 3. Our equation would still have been y equals a half x plus 3. And finally, as before, find the gradient. So that's negative 10 downwards, 5 across, so it's sloping downwards, so this is a gradient of negative 2. And we substitute the values of negative 4, 7 into our equation. There's the y value substituted in, there's the x value substituted in, and we end up with c equaling negative 1. And our final equation, y equals negative 2x subtract 1. And as before, if we'd have used the other coordinate and substituted that in, I'll just go through this reasonably quickly, we still end up with the very same equation, y equals negative 2x subtract 1.